In this video, we are going to talk about the fundamental theorem of calculus part 1. We have to keep in mind that the fundamental theorem of calculus has two parts, part 1 and part 2. But in this video, we are just going to focus on part 1. Now, we consider a function that we label little f. So little f here is continuous. So the condition is it has to be continuous on an interval a, b. Now from this function we define a new function, capital F of x, as being the integral from a to x of f of t dt. If this is the case, then the derivative of that function, capital F of x, is equal to little f of x. Now how does that work in practice? Let's go over the first example. Example 1. We suppose that g of x is equal to an integral from 0 to x square root of 1 plus 2t dt. Now they want us to find g prime of x. Now how do we find g prime of x? The first thing is rewrite this function, and wherever you see the variable t, replace that variable with a box. So g prime of x equals, I'm rewriting that function, square root of 1 plus 2. Instead of writing t, I'm writing a box there. That's the first step. The second step is what you plug into the box is this upper limit, x. So I'm just plugging x there. So g prime of x is equal to square root of 1 plus 2x. And that's the final answer. And something that I want you to note is always make sure that the constant, the number, is the lower limit. If it's the upper limit, then there are ways to work around that. And we will see that in one of the upcoming examples. Let's go over the second example. So example 2. Example 2. Consider capital F of x to be the integral from 3 to x squared square root of 1 plus t cubed dt. We want to find f prime of x. So how do we proceed? You take the function that's inside, and the good thing about the fundamental theorem of calculus part 1 is we don't have to find any antiderivative. So the function is there, square root of 1 plus t cubed. But first of all, before we even do that, we have to make sure that, the number is the lower limit, which it is the case here. So we don't have anything to do in that regard. So we take the function that I circle in blue, I rewrite it, and everywhere I see the variable t, I replace it with a box. So f prime is equal to square root of 1 plus, it should be t cubed, so box cubed. But what do I put into the box? I put the upper limit, and the upper limit here happens to be x squared. So I'm going to write x squared into the box. But we are not done yet, because the upper limit is not just x. If it's just x, then we would have been done. But it's x squared. So we have to multiply this expression now by the derivative of that upper limit. So what's the derivative of x squared? Is 2x. Now we are done. So always multiply by the derivative of the upper limit. So we can then rewrite this properly without boxes. F prime of x is equal to square root of 1 plus, here we have x squared to the power of 3, that's x to the power of 6, and then times 2x. So that's the derivative. So once again here, when the upper limit is not just x, do not forget to multiply by its derivative. Let's go over another example. So example 3. Example 3. Let's say we have f of x is equal to e to the 2x, 0, and then cosine to the power of 4t dt. They want us to find f prime of x. Now, what do we notice here? We notice that the number is not the lower limit. We can fix that. So we have some rewriting to do. So we rewrite f of x is equal to, we're going to flip the limits, 0 would be underneath, and e to the 2x would be on top. But now do not forget, when you flip the limits of an integral, you multiply by a negative sign, and then everything remains the same. So cosine of to the power of 4 of t dt. Now we are ready to compute the limit, or not the limit, the derivative. So f prime of x is equal to what? I'm carrying the negative sign over, and I'm going to rewrite the function, the inside function, exactly the way it is, and replace t by a box. So cosine to the power of 4, and then a box. What do we put into the box? The upper limit, which is e to the 2x. But once again, we realize that the upper limit, e to the 2x, is not just x. So we have to multiply by the derivative of that upper limit. Now, what's the derivative of e to the 2x? Is 2e to the 2x. So if you're rewriting this properly by bringing, for example, this expression up to the front, then we have f prime of x is equal to negative 2e to the 2x times cosine to the power of 4 e to the 2x, and that's the derivative of the function. So the takeaway here that you always have to remember is that you have to make sure that the number is the lower limit. If it's not the lower limit, do exactly what we just did on example 3. And then the second step is you take the function that you're taking the integral of, you rewrite it. Wherever you see the variable, if it's t, replace all the t's with a box, and what you plug into these boxes would be the upper limit, and then don't forget to multiply by the derivative of the upper limit. Now, to practice, I'm going to assign some problem so that you can practice the skills. So find the derivative of these three functions.